Hello, my name is Ms. Midha, and today we're going to be looking at the following question. How do we identify the midline of a trigonometric function? Now, before we get into this concept of midline, I want to do a review of another concept that you've learned about for trig functions, and that is amplitude. And I want to talk about amplitude first because that really gets us ready to understand what midline is all about and where it is in our trig function. So you may have seen this example before. What you'll notice here is that you have three different sine functions. You've got a green one, a red one, and a blue one. And then you have three different sine equations. Y equals 3 sine theta, y equals sine theta, y equals 0.5 sine theta. So what I'm going to ask you to do is, after I explain, I'm going to ask you to pause the video and see if you can figure out which equation matches with which graph over here, right? Which graph is going to match y equals 3 sine theta, which one y equals sine theta, which one equals 0.5 sine theta. So go ahead and pause the video. Once you think you have the answers, just unpause the video and we will continue. Okay, my green function, my green sine graph, this is y equals 3 sine theta. My red one, y equals sine theta. And my blue sine function is y equals 0.5 sine theta. So those are the equations for each of these graphs. Now the real question is this: how did we know this? Well, if I think about the graphs themselves, forget about the equations for a minute. If I really just focus on the functions themselves, but they're all sine functions. But what's different about them really is this thing called a vertical stretch, right? You may remember that term from work in earlier units, this idea of vertical stretch, right? And if you look at, if I look at my red function, y equals sine theta, and I compare it to the green one, y equals 3 sine theta, I can notice that that green sine function is a lot more stretched out. It's been vertically stretched, right? So this idea applies to trig functions as well. So the difference in our vertical stretch is really what's going to help me figure out what my equations are. And then if I look at the actual equations as well, what's different about each of these equations? There's only one thing that's pretty much different amongst all three of these, right? And it's the number that's directly in front of our sine. So that number, again, there's no number in front of y equals sine theta, but really there is like an imaginary one there. So just keep that in mind. But that number, right, that coefficient, that number is actually what is changing the height of each of our graphs, right? It's stretching. You'll notice also the blue one, it's like smushed down. But that number, that coefficient, is changing the height. It's responsible for this height of each graph changing. So in more sort of like generic terms, if I just write h equals k sine theta, and this works for cosine theta as well, and I'll show you an example of that in just a minute. But if I write it in that fashion, right, the k, that parameter k in these equations, that's what changes the height of each graph by a factor of k, and the absolute value of that is called the amplitude, right? So what's my k in my function y equals 3 sine theta? My k is that 3. And so that 3 is changing the height of each function, of this graph rather, by a factor of 3. What about my function down here, the blue one, 0.5 sine theta? 0.5 is the k, and that is changing the height of this function by a factor of 0.5 or 1/2. Okay, and this is called the amplitude. So this same thing applies for cosine, and I'll do a quick example with you right now for that. Here you'll notice we have a cosine function that's already been graphed, y equals cosine theta. And here is asking you to graph the cosine function with an amplitude of 2. So I'm going to ask you again to pause the video and see if you can figure out how to graph this, and then unpause when you're ready. Okay, now remember, the amplitude is really telling us what our height is. So just to sort of backtrack, I can tell with my y equals cosine theta that my height of this function is 1, right? That's how I know it's technically a 1 there. It's imaginary, but we see it. So if I wanted to graph a cosine function with an amplitude of 2, well, what would my height be? My height would be 2. So that would mean that my maximum values for this new function would be at 2, and my minimum value would be at -2. I'm not done yet, right? I still need to add in my zeros. So I know my zeros are going to be at pi over 2 and 3 pi over 2. And once I have that, well, then I can just go ahead and graph my cosine function. So again, the only thing that's changed is this vertical stretch. How do I write the equation for my new cosine function? Y equals 2 cosine theta. Again, the only thing that's changing here is the amplitude, and the amplitude is always going to be represented by that number directly in front of my cosine function, right? It's the coefficient. So that's amplitude. Now we're going to move on to this thing called midline. So in order to do this, what I'm going to ask you to do is as follows. You're going to go to Desmos, and you're going to graph these two functions. H is equal to sine theta plus 8, and H is equal to sine theta. And again, pause the video. You're going to go to Desmos. And what I'd like you to do is really to compare the two graphs, right? What's similar about them? What's different about them? So go ahead again, pause the video, go to Desmos, graph H is equal to sine theta plus 8, H is equal to sine theta. And then when you're ready, unpause and we will continue. Okay, so you'll notice here I have my function sine of theta. Now, the only one that's being shown right now is my, sine of theta function. And I'm going to go ahead and add sine theta plus 8. All right, there's my sine theta plus 8. Sine theta plus 8, right? Red is sine theta, green is sine theta plus 8. So what's the same? Well, what is exactly the same is the shape, right? The shapes are identical. What's different though? Well, what we notice is that our sine theta plus 8 has essentially been translated, right? It's been translated up 8 units. It's been translated up 8 units. This is called a vertical translation. Okay, so again, what's the same? They have the same general wave-like shape, that same pattern. But the thing that's different is that the translation has moved up. It's essentially been translated upwards by 8 units. And I have another function here, sine theta minus 3. Where do you think this is going to go? Down 3 units, right? Same shape, but it's been translated 3 units down. So notice the difference here, right? Notice the difference in what's happening to our function. Notice the difference in the actual equation itself. Where did the numbers get added now? Right before, when we were looking at amplitude, here's the same examples from before. When we were looking at amplitude, the number that was affecting the height of our function was directly in front of our sine, right? I had y equals sine theta. There's my y equals 3 sine theta. Again, notice it was vertically stretched. Y equals 0.5 sine theta, right? That's what was happening before. The number directly in front of our function was really changing the height of our function. But now the height's staying the same, right? The height is exactly the same. What's changing is where the function is, essentially, right? It's being moved up. And I'll just focus on the two that we were working with. It's being moved up 8 units compared to the previous one. Okay, here's another question for you now. Looking at this function, sine theta plus 8, and I'll just zoom in on this just a little bit more. What would you say is the middle value for the outputs of this function? Where do you think the middle value for the outputs of this function are? So again, pause the video, sort of think through this. See if you can figure out where are the middle values, or what would you say is the middle value for the outputs of this function? Okay. Well, if I look closely, it really looks like the middle value is right here. It's at 8, right? It's almost like the visual center of this sine curve. It's really directly in the middle. So this 8, and I'm going to highlight the equation again just to remind us where it was in the equation, right? So this 8, and I'll do it one more time. This is the visual center, right? This visual center of the graph is called the midline. Okay, this is what the midline is. So the midline here, it's really telling us the visual center. Where's the middle of this function going to be? Okay, so we've done a lot already, right? We've looked at amplitude. We've seen that the number in front of our sine or our cosine function, that coefficient, that's going to tell us what the amplitude is, which is our height, right? It's affecting the height of our function. And the midline, it's the number directly after. It's being added or subtracted. And it's essentially like our vertical translation, right? Where is it being shifted up or shifted down? Now we're going to put both of these ideas together. So here goes. Okay, take a look at this function now. Y is equal to 2 sine theta plus 8. Now what's going on here? Well, a lot's going on here, right? Let's sort of think this through. Okay, so I notice in my function, I'll just look at the equation. I notice that there is a number 2 in front of my function, directly in front of my coefficient. And that's going to tell me that I have an amplitude of 2. I also notice that it says plus 8 at the end. That plus 8, that tells me my midline, right? Knowing those two pieces of information, I'm actually able to graph this function. And so what you'll notice, right, the midline, again, it's like our visual center, it's the middle. If you look at this function, you can actually really tell that the midline, well, it is in fact at 8, right? It's literally directly in the middle. Now, again, our amplitude, what is our amplitude? Our amplitude is really the height of our function, right? It's helping us determine the height of our function. And once you have the actual midline, once you know what the midline is, you're able to determine what your amplitude is, because your amplitude essentially, it's really like the maximum and the minimum values that are above and below the midline, right? That's really what the amplitude is if you think about it. It's really like that idea of like the maximum distance from your midline as well as your minimum distance, right? So it's measuring almost the length from the midline to the max and the length of the midline to the length of your midline to your min. So here it's saying the amplitude's 2. So that means from the midline, my height is going to increase by 2 units. And then it's going to have a minimum below the midline of 2 units. And I can tell right there, right? This is at 10 and that this is at 6. So when you're dealing with amplitude and midline, it's actually really important to know both of them to help you graph specific situations. Okay, so to summarize, what did we look at? We looked at the midline and the amplitude. The midline, it's the value halfway between the maximum and the minimum values of a periodic function. Also the horizontal line, whose y-coordinate is that value. And it really does help to draw in that dotted line, that dashed line, to really show where the midline is. Well, if you do that, you can really kind of figure out where your amplitude is a lot quicker. An amplitude, the amplitude of the function is the length from the midline to the maximum value, right? It's shown with this dashed line right here. This dashed line, that's telling us from the midline, we're going up to our maximum value. That's our amplitude, right? That length. And it's also telling us the length from the midline to the minimum value down here as well. So one final example, if we look at this, right? It's telling us the equation of this function is y equals 11 sine theta plus 11. Why? Well, because our midline is at 11 right here, right? That's why we have that horizontal dashed line. And the length from the midline to the maximum value right here is 11. Hence our amplitude is 11 and our sine on our midline is 11. So two really, really, really big important concepts, midline and amplitude.